Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present two topics from subject MAT112, Business Mathematics. Before we start the presentation, I'm going to introduce my team. The first one is Noor Nayli. You can call her Nayli. Hi. The second one is me. I am Aqilah Nasuha. You can call me Nasuha. The third one is Dianah Wafiah. You can call her Dianah. Right. And the last one is Siti Sarah. You can call her Sarah. Hi. So we will present about topic 5 and topic 6 in MJP112, which is compound interest and end. So I'm passing the floor to Dianah.
Hi everyone. So let's start with compound interest topic 5. So what is compound interest? Compound interest is calculated on the original or principal value and the accumulated past interest. So for example, if you borrow some money from a bank, of course you will have to pay for the interest. If you want to know how much interest you will earn on your investment or how much money you will pay above the cost of the principal amount of the loan, you need to understand how compound interest works. So in this topic, we will learn how to use compound amount formula to find the future value, compound interest, and present value of investment. So this is the subtopic that we will learn today. So let's start with 5.1, compound interest. Compound interest, as you know, simple interest computation is based on the original principle, which does not change from time to time. For example, if you need to pay 100 ringgit for the first month for the simple interest, so you have to pay 100 ringgit as well for the second month and the third month. Right? Compound interest is based on the current principal, which change from time to time. The principal value increases from time to time according to the compound interest rate. For unlike simple interest, compound interest needs you to pay, for example, you have to pay 100 ringgit for the first month, but it doesn't mean you have to pay 100 ringgit for the second time, for the second month. Maybe you have to pay 200 ringgit or maybe more than that for the second month, and it will increase for the third month, fourth month, and so on. Let's move on to 5.2, some important terms. In this topic, we've got original principle as interest period is the length of time in which interest is calculated. Uh, Number of interest period is set by n also known as NP, and P is calculated in years. Nominal interest rate is the interest rate for a year together with the frequency in which interest calculated in the year divided by K. And periodic interest rate is the interest rate for each interest period. Thus, the periodic interest rate divided by I is also known by K% over M. So what is M? M is the frequency of conservation, the number of interest period calculated in a year. So the question will tell you that it will be compounded annually or semi-annually or quarterly, like according to the question. So you will get your M based on the question get. Let's move on to 5.3, compound interest formula. So this is the formula, the only formula that you will use in this topic, which is S equals P in bracket 1 plus I powered by N. So as I said before, I is also known as K% over M, and N is known as MT. S is future value or accumulated amount. P is principal value or initial value. I is periodic interest rate, and is number of interest period in the investment. Other than that, this topic also have another formula, but it's not as important as the first one, which is I. To find I, you have S equal minus B. Okay. I is the difference between future value and principal value. 5.4 is present value. It's the same formula as before, but you need to change a little bit from the previous formula to get this new formula to find present value. And for 5.5, 5.5 is very interesting because we have three different cases for this topic. The first one is if you want to withdraw sum of money from your account. Let's for example, the question is RM 2,500 was deposited in a saving account at 10% compounded semi-annually. After 2 years, 700 was withdrawn and the balance was invested for another 3 years. Calculate the amount in the account at the end of the investment period. So, firstly, you have to find the amount at the end of 2 years using the formula, and then you will get the answer is 3,358 ringgit 77 cents. After that, you minus 700 from this answer because you withdrawn 700 ringgit. That means take out the 700 ringgit from the bank account, and then you will get the new principal amount. So if you want to find, so the answer needs you to calculate the amount in the account at the end of the investment period, which is 5 years. So if you want to get the answer, use the same formula but change the P amount to the latest principal you get. And this is the answer, which is 3,134 ringgit and 80 cents. And for the second cases, if you want to add some money in the bank in your bank account. For the example question, Halima saved 7,000 in the saving account, which pays 6% compounded monthly. 8 months later, she saved another 1,500. Find the amount in the account 3 years after her first saving. Same as before, find the amount of 7,000 investment after 8 months using the same formula, and then you will get answer 7,284 ringgit 95 cents. And then add 1,500 ringgit to the amount because Halima saved another 1,500. And then same as before, the question wants the amount in the account after 3 years, after her first salary, which is 3 years. So using the amount you get after you add 1,500, you will get the answer is 10,101 ringgit 57 cents. The last cases is there's any changes in the nominal rate. The example, the question is RM 5,000 is invested for 3 years and 6 months. This investment is of 12% compounded monthly for the first year and 8% compounded quarterly for the ensuing period. Calculate the future value of the investment. So find the amount on first year using the money formula in this topic, and you will get the answer 5,634 ringgit and 13 cents. And then using the same formula but change the rate from 12% to 8%, and the amount of M from compounded monthly, which is 12, to compounded quarterly, 4. Then you will get the answer is the final answer is 6,867 97 cents. And I think that's all from me. I'll pass the slide to Sarah to explain to you the questions for this topic.
For the question 1A, Ahmad invested 12,500 ringgit at 8.5% compound quarterly for 12 years. Find the amount at the end of investment and the interest rate. For the find the amount of the end at the end of investment,
we use formula S equal P in bracket 1 plus K% over M power of NT. 12,500 ringgit in bracket 1 plus 8.5% over 4 power of 48. And the answer is 3,004 296 ringgit 46 cents. And for the interest earned, we use formula I equal S minus P. 3,004 296 ringgit 46 cents minus 12,500. So the total is 21,796 ringgit and 46 cents. For question 8 years ago, right-hand investors RMS at a bank which offer an interest rate of 8.5% compound semi-annually. If the accumulated amount in the account today is 5,618 ringgit 95 cents. For the first, find the value of X. So we use formula S equals P in bracket 1 plus I power of A. 5,618 ringgit 95 cents equals P in bracket 1 plus 0.0425 power of 48. The answer is 2,886 ringgit 94 cents. For question 2, if another 1,500 is added in the same account today, find the compound amount at the end of the next 2 years. 2,886 ringgit 94 cents plus 1,500. And we can get 4,386 ringgit 94 cents. And we use formula S equal P in bracket 1 plus I power of N. And 4,386 ringgit 94 cents in bracket 1 plus 0.0435 power of 4. And the answer we can get 5,181 ringgit 60 cents. And for the next, I will pass for Nayli.
Let's continue, guys. So next topic is I will explain about anime. So first of all, I will introduce what is anime. So anime is a series of equal moments made at an equal interval of time. So basically, anime we use it short rental, insurance policy, and installment and also more. and equal payment. Uh, and in some case, equal payment is received or benefited critically over time. Like for instance, I make a deal of a bank and I'm deciding to pay the loan every 2 months in around 200. So basically, I have to pay another 2 months and another 2 months with the same amount. So our learning objective for this topic is we have learning objective, which is find the value of the energy, find the present value, uh, solve the energy payment and the number of payment, and also identify the problems where the present value and future value of the energy formula can be applied. So this is our subtopic. So let's move on with our first subtopic. For the first one is 6.1, which is the future value of ordinary annuity today. So future value, or can also call accumulated value, is the sum of all the future value of the credit payment. And credit payment, what is credit payment? So credit payment is a term that can be equal to the frequency of collection. Like, for example, if the nominal rate compounded quarterly, the credit payment must be averaging one. Okay, so that is how explain you about the future value formula. So the main formula is S, which is the future value, and which is S equal to R in bracket 1 plus I in bracket powered by N minus 1 divided by 1, divided by I, sorry. So what is R? R is a monthly payment that we pay, and I is the key percent or percent, which is the rate of interest divided by the frequency. So if you want to, so from this formula, if you want to earn the interest, we have to use the formula which is I equal to S minus N multiply R, which is N is the number of the payment and R is the total payment and S is the maturity value and R is its interest. So next, 6.2, which is the present value of ordinary annuity today. So present value, or we can call initial value, is the sum of the present value of yearly payment. So present value formula, we use the letter of A. So the formula is A equal to R in a bracket 1 minus 1 plus I in a bracket powered by negative N, the N divided by I. So like I said before, at the future value formula, um, and for the interest, we can gain the interest from this formula by using the I equal to NR minus A. So let's move on. Let's move on for 6.3. So for 6.3, credit payment, number of payment, and also formula application. So there are two in this topic. There are two main formula that we should know, that we have to know, that very important to know. So the two is, which is the future value formula and also um, and also present value formula, which is so when we can use this formula for the future value formula, we can use when the question give us either future value or maturity value information. But for present value, we can use this formula when the question gives us the initial value or present value information. So next, let's move on to 6.3.1. So how we want to find the credit payment, which is the R, using this annuity formula. So I give that two examples, right? So for the first example, like the question say, Marina makes a loan of RM 150,000 from a bank that charged her 6.5% compounded money for 50 years. So from this question, they already gave us the present value, which is the 150,000, which is the present value. And so we have to insert all the information given, and uh, we can find the R. And after we find the R, if we want to find the interest charge, we can just use the formula of I equals to NR minus A, because uh, we we use the present value formula. So for the example 4, uh, the question says an investment at the rate of 8% compounded monthly that will amount to real amount. So the key point is a real amount to 30,000 at the end of 10 years. So we know that the 30,000 is the future value. So we have to use the formula of S. And also, if we want to find the interest, we have to use the formula of I equal to S minus NR. So let's move on. 6.3.2, the number of payment, which is N. So I give one example here, which is Kamil has to pay around 443.21 cents every month to settle a loan of 10,000 at 6% compounded monthly. So this question already gave us um, the R, the A, and also I, and also M. So from these, we can search the power N. And we can search the number of payment, which is the N. So for this, to search to find number of payment, we have to use log, and just in use log and move the number to number family, and we can find the annual. So for question B, see, the question say that Azli deposits 691.74 ringgit every month. The investment that in 3.6%. So compounded monthly with the maturity value. So the question already state maturity value, so we have to use the formula of S. Just insert the information given, and you will find the N. So that is, so let's move on for 6.33, the formula application. So for A is missed payment. So what is a missed payment? So it's when the increment in interest charge, which is the borrower needs to pay more than the total missed payment. And for example, if borrower missed 3 payments, she needs to settle the outstanding balance on fourth payment. So the number of future value will increase because of the missed payment. So how we want to know? We just have to find the future value of in for payment. So that is B. So so for B, make full settlement earlier. So in this case, the borrower needs to pay less than the total single payment, which is the interest will be reduced because uh, she will make the first statement uh, earlier. So, for example, if borrower make a first payment after after 30th payment instead of 38 payments, so she just need So she will reduce the payment and let and get more. So she will reduce the interest. So that's all about me, and I will pass this slide presentation to Nasuha for review of the question two. Thanks, Lance. I'm gonna continue with question two. Question two A. Zaid must pay 1,300 ringgit every month for 25 years to settle the housing loan with charge 3.5% compounded monthly. Calculate the cash price of the house and the total interest charge. So here you can state that 1,300 ringgit as R 25 years as 3.5% as rate, and it compounded monthly, which is 12 months. So, uh, to calculate the cash price of the house, we can use the formula A equals R bracket 1 minus 1 plus I power negative n over I. So we can fill in the information that I have put before this. A equals 1,320 bracket 1 minus 1 plus 0.035 over 12 power negative 300 over 0.035 over 12. And the answer is 259,676 ringgit and 15 cents. These are the answers for the cash price of the house. And for the interest charge, we can use formula I equals to NR minus A. Fill in the information that same as before. And change to 300. R is 1,300 ringgit minus 259,676 ringgit and 15 cents. So the answer is 113,323 ringgit and 85 cents. So this is for question 2A. For question 2B, Kamal decided to buy a television set for 8,000 ringgit and agreed to pay for it with 24 equal monthly payment at 1.5% compounded monthly. So here we can state the A, which is 8,000 ringgit, and the I is 0.15 over 12 months, and the N is 24. So, for question B1, calculate the monthly payment, or R. So, we can use the formula A equals R, 1 minus 1 plus I, power negative N over I. Let's fill in the information, same as before, which is 8,000 ringgit equals R, 1 minus 1 plus 0.15 over 12, power negative 24 over 0.15 over 12. And the answer for R is 387 ringgit and 89 cents. For question B2, calculate the interest paid by Kamal. We can use the formula I equals NR minus A. Fill the information with 24 multiplied 387 ringgit and 89 cent minus 8,000 ringgit. And the answer is 1,309 ringgit and 36 cents. For question B3, if Kamal failed to pay for the first trip payment, how much should he pay on the fourth payment to settle the outstanding errors? To settle the payment, we can use formula S equal R bracket 1 plus I power n minus 1 over I. Then just fill in with the information with S equals to 387 ringgit and 89 cent bracket 1 plus 0.15 over 12 powered 4 minus 1 over 0.15 over 12. And the answer for S is 1,580 ringgit and 89 cent. So that's how the question to so that's how for the question 2. So that's all from us. Thank you for listening and enjoy the learning. Bye.